Good day, everyone. I am Emeline Espanta, a BSE student from Eastern Visayas State University, Ormoc City Campus, and today I will be discussing my solutions for the short exam on Module 3. So, the short exam has a problem, and the problem states that a 220 volts long shunt compound motor has an armature resistance of 0.27 ohm and a series field resistance of 0.05 ohms. So the full load speed is 1400 RPM when the armature current is 75 amperes. So at what speed will the motor operate if at no load if the armature current drops to 5 amperes and the flux is reduced to 90% of its full load? So assume that the brush drops to be 2 volt at full load and 1 volt at no load. So showing my solution here, the given we have an armature voltage of 220 volts. We have an armature resistance of 0.27 ohms, a series field resistance which we have here 0.05 ohms, and given that at full load we have speed of 1400 rpm, and given that an armature current we have here 75 amperes. At full load we have a speed of 1400 rpm and it has an armature current of 75 amperes. So, and also I have put here that we have to assume that the brush drops at 2 volt, and then in full load, and then in no load the brush drops at 1 volt. So we have to find at no load what is the speed if the armature current drops to 5 amperes and the flux has 90% of its full load. So given that we have a formula, we have the armature current is equal to the V subscript A minus the counter EMF over the armature resistance from the plus resistance. So we simplify the equation and we can get the equation for the EMF. So we have the counter EMF is equal to the voltage armature minus the current the armature current times the armature resistance plus the resistance. So we also have another formula for the EMF, which is K, which is given K is a given constant times the flux times the speed. So here in my solution, at full load, I have the given formula for the counter EMF, which we have as what I've mentioned earlier. So we're complete with the given, so we input the given on our formula. So we have 220 volts minus 75 times 0.27 plus 0.05, so we can get a value of 194 volts. So at no load we have, using the formula of the counter EMF, we have E subscript C is equal to VA over a minus a armature I, or the armature current, times R, the armature resistance, plus R. So we have the given values. We input here, we have 220 volts minus 5, since the it was stated at if what is the speed at no load if the current drops on 5 amperes. So we have here the armature current changed, which we have here, and for no load we have 5 amperes times 0.27 plus 0.05. So we can obtain a value of counter EMF, which is equal to 17.4 volts. Proceeding with the solution, we divide the counter EMF over the counter EMF for the no load. We divide the counter EMF for full load and over the counter EMF for the no load. Since we have here equation for another equation for EMF, counter EMF, I mean. So we have equal to K times um, flux times the speed at full load over K times flux times the speed for no load, which we need to find. Since since we have now the formula in getting the speed at no load, and we also have the values for our counter EMF at full load and counter EMF at no load. So substituting the given on our formula, we have 194 over 217.4 is equal to K times flux times 1400 over K times 0.90 times the flux over times S subscript and L. So the S variable S subscript and L is also called the speed, the variable that the unknown that we need to find, the unknown value that we need to find. So it has a condition that at no load the flux is 90% of its full load. So I have put here 0.90. So simplifying the formula or the equation, so the k, the variable k, and the phi, the variable phi, will be cancelled. So we will be left with this values. So I have simplified 194 over 217.4, which I have here a value of 0.89236 is equal to 1400 over 0.90 times S subscript and L. So for further simplification on the equation using cross multiplication, we can using by putting the unknown variable or the unknown value or the unknown variable on our left side and the known variable on the right side. So we have here S subscript speed at no load is equal to 1400 over 0.90 times 0.89236, and we can obtain the value of our speed at no load, which we have 1743.19 rpm. So now the answer in which at no load, the speed for no load, which we have a condition that the armature current drops at 5 amperes and the flux has 90% of its full load is 1743.19 rpm. So that will be all. Thank you.